In early 2002, a star called V838 Monocerotis suddenly surged in brightness. At first, that might not sound unusual. Stars erupt, telescopes catch unexpected outbursts all the time. But as observers kept watching, the event refused to settle into anything familiar. The star did not simply become brighter, it kept changing in ways that made it harder to recognize. Each new observation revealed a different version of the object than observers thought they were tracking. Each new observation added detail, yet the picture became less stable. The object now sitting in the sky looked increasingly unlike the kinds of stellar eruptions astronomers were used to classifying. That created a problem almost immediately. The normal categories were supposed to help explain what was happening. Instead, the categories themselves began losing reliability at the exact moment they were needed most. The more closely V838 Monocerotis was examined, the less confidence those labels seemed to provide. This no longer looked like a routine star suddenly releasing energy. Something physically different appeared to be unfolding, and nobody could yet say what kind of event they were actually watching. The simplest explanation was still hanging on. Maybe V838 Monocerotis was not creating a new kind of event at all. Maybe it was simply an unusual version of something astronomers had seen before. Strange did not automatically mean unknown. An outburst could still be an outburst, but that possibility kept losing ground. As the observations continued, the star's behavior repeatedly drifted away from what those familiar explanations expected. Each new round of data was supposed to narrow the possibilities. Instead, it removed them. Observers would settle on an explanation. Then the star would change again. A category would seem close enough to use. Then another shift in the object's appearance would pull it back out of reach. The process became less about finding the right label and more about watching existing labels fail. That failure had a practical consequence. Classification systems are useful because they allow predictions. If an event belongs to a known category, observers can make reasonable expectations about what might happen next. But every time V838 Monocerotis behaved in a way that conflicted with those expectations, another piece of predictive confidence disappeared. The problem was no longer that the object looked unusual. The problem was that the safest explanations were being eliminated one by one, and nobody yet knew which observation was forcing them to fail. For a moment, the situation seemed to stabilize. Researchers began identifying explanations that could account for at least part of what V838 Monocerotis had done. The event still looked unusual, but unusual was easier to accept than completely unknown. If enough of the observed changes could be connected to known stellar behavior, then the mystery might be shrinking rather than growing. That possibility mattered. The object in the sky was still changing, but now there were frameworks capable of following some of those changes. Instead of watching explanations disappear, observers could point to models that appeared to fit important pieces of the transformation. The match was not perfect, yet it was close enough to restore a measure of confidence. The pressure that had been building around the event began to ease. For the first time since the eruption began, the event looked as though it might return to familiar territory. A strange star was no longer automatically a new category of phenomenon. It could still be an extreme example of processes that already belonged within familiar ideas about stellar evolution. The classification problem that had seemed so unstable suddenly looked more manageable. And if that interpretation was correct, the next stage should be straightforward. Future observations should simply confirm what was already becoming clear. The star might remain unusual, but its behavior should gradually begin falling into line with expectations. The expectation now seemed clear. If the explanation was correct, future observations should reinforce it. The strange behavior of V838 Monocerotis might still contain surprises, but those surprises should remain inside a framework that already existed. The model did not need to be perfect. It only needed to keep pace with reality. Then reality pulled away again. As new observations arrived, features began appearing that the temporary explanation had not successfully anticipated. The star continued changing, but not in the way the explanation said it should. Details that should have fit comfortably inside the predicted picture instead created fresh mismatches. At first, those mismatches looked manageable. A single discrepancy can be adjusted. An unexpected feature can be treated as a complication. But the pressure kept building. The more the object was observed, the more difficult it became to reconcile what was actually happening with what was supposed to happen. What observers were seeing no longer matched what they expected to see next. The problem was no longer appearance. The problem was prediction. An explanation earns confidence when reality keeps agreeing with it. Here, each new observation became another test, and one by one, those tests stopped producing the expected result. The explanation that had briefly restored stability was now struggling to reproduce the very behavior it was meant to explain. That changed the nature of the event. V838 Monocerotis was no longer just a strange object that resisted classification. The failure now reached deeper. Behaviors that seemed understood no longer looked as predictable as they once had. And if those assumptions could fail here, it became difficult to know where else they might be failing without anyone noticing. V838 Monocerotis did not become important because it produced one unusual outburst. It became important because the event exposed a gap. A star, one of the most familiar objects in the universe, moved through an extreme phase that existing models had represented poorly. Observers watched the transformation unfold in real time. They tested explanations against new observations. They adjusted assumptions. They looked for a version of the event that fit comfortably inside established expectations. Again and again, reality forced those expectations to change. The consequence reached beyond a single object. The failure was not that one prediction turned out to be wrong. The failure was discovering that confidence had extended into territory that was not actually understood. A process that seemed mapped and categorized still contained behaviors humanity was not prepared to recognize when they finally appeared. That is what V838 Monocerotis ultimately revealed. The most significant discovery was not simply what happened to one star. It was the realization that stars may pass through extreme phases that existing ideas only partially describe. The sky did not change. The limits of our understanding did. A familiar star had exposed a blind spot hidden inside a system that seemed mature and well understood. And the cost of relying on incomplete models is that something genuinely new can unfold in plain sight, while everyone is still trying to fit it into a category that no longer works.